Good afternoon, everyone. Today we are going to discuss how to effectively create a coordinate geometry proof. And the nice thing about coordinate geometry proofs is that in general they are very straightforward, and from a strictly proof standpoint they're going to be pretty simple. The complexity really comes in where you have to be sure to show exactly what you are doing. So the correct and thorough demonstration and justification is what we're looking for on the coordinate geometry proofs. So typically you will be using distance formula, slope formula, and midpoint formula. So let's look at the overall process. When developing a coordinate geometry proof, you want to draw and label the graph. You want to draw your graph with a straight edge. You want to state the formula you will be using, and that can be listing the formula. You don't have to write a sentence at this point. You're going to show the work in a very descriptive manner, including your sketches, your coordinates, your formulas, etc. And then at the end, you have a conclusion stating what you have proven and why it is true. So in terms of the actual proof itself, it's not going to look like our typical two-column proof. It's going to be more mathematical. Let's look at example 1. We are asked to prove that a triangle is isosceles. So the easiest way to prove that a triangle is isosceles, its definition. That's going to mean you have to prove that at least two sides of the triangle are congruent. So congruent implies equal, equal implies length, and length implies distance. So in this case, we're going to be using the distance formula. Now you always do want to read the question carefully because sometimes there's either multiple steps or you have to first prove something in order to get to another conclusion, because sometimes we get so caught up in the work that we're doing that we forget to actually go back and answer what it is that they asked. Okay, the first thing we're going to do is we're going to take those coordinates and graph our triangle. We're going to have very straight sides to our triangle using a straight edge. I want to make sure my X and Y axis are labeled if they are not already. I want to make the drawing clear and neat. It needs to be very obvious what my picture looks like. Then I am going to state the formula I'm using. Now notice the formula is completely written out here. You need to do that, and then you will plug in, and then you will solve completely. And now notice we can tell by our picture probably what the two congruent sides are. And for isosceles, I need only prove two congruent. So I can kind of cheat here and pick the two sides I want to prove congruent. And notice that I am actually very specific about which sides they are. So I don't just put a D here, I actually put the sides that I'm looking for, AB and BC. Now we get that AB and BC are both equal to the square root of 13. As I've mentioned in the past, you want to be careful here. If this had been something like the square root of 80, for instance, and the square root of 80 here, I do not really want to simplify unless they've asked me to do so. And the reason being, if I simplify incorrectly, then I'm going to lose credit. So it's sufficient to show that radical 80 is equal to radical 80. I don't need to make that for radical 5. My work must be descriptive. I need to be showing what I'm doing. Since we're looking for two sides of equal length, I can stop when I find that I have found two sides of equal length. And then the most important part is to have that concluding sentence stating exactly what you proved. Why do I know the triangle is isosceles? It is isosceles since it has at least two congruent sides, those being AB and BC. Pretty straightforward. Example 2, we're asked to prove trapezoid. Now, although we have not done quadrilaterals at this point, I think most of you have a fundamental idea of what a trapezoid looks like. There has been a little controversy over the definition of a trapezoid recently, but the definition of the trapezoid we are working with states that a trapezoid tells us a figure has at least one set of parallel sides. I need not worry about the other sides. So since parallel has to do with slope, I'll be using the slope formula. So the first thing I'm going to do is draw my picture, and it needs to be neat and labeled. Notice I've stated the slope formula. Now I realize you have been doing slope formula for a long time. You know what it is. Do you need to write it out then? Of course you do. And not only because it is required for this type of a proof, but because when you're doing these things, it's amazing how careless we can be. And I've seen many, many times where students don't write the slope formula and then they're doing delta x over delta y. So you want to be careful because this is kind of your roadmap. Here it is, y2 minus y1 over x2 minus x1. It is very descriptive. I'm not just saying slope equals. I could write the m and then a subscript BC like that. That's saying the slope of BC. But I do want to be very specific which side I'm finding the slope of. And here, of course, we get 2/3 for both of them. And then I can say they are parallel because their slopes are equal. So my work is descriptive right through here, and then I have this fundamental last piece, which is my concluding sentence stating how and why I know that this figure is in fact a trapezoid. QED. We're done. So I think you will find these overall not the most challenging of proofs in terms of the actual proof itself. Some of you, those who are less likely to show your work, might find them a little frustrating because you will lose points if your work is not clear and descriptive. So on that note, I would like to sign off and tell you all to have a great night.